Okay, we're ready to look at video 15C. We're going to continue with confidence intervals. This lesson contains 2 examples, so let's get started. You might recall from lesson 14 we had looked at an example with compulsive gamblers, so we're going to return to that. We looked at the percentage of the population that were classified as compulsive gamblers. The last reported value was 1.2%. But here in Maryland, we had taken a random sample of 1,200 adults and diagnosed 15 as compulsive gamblers. So let's say that we would like to create a 99% confidence interval for the true proportion of Maryland adults who are compulsive gamblers. And we'll first check our conditions. So we're to create a confidence interval. We've been working with proportion problems. Eventually we'll throw in some mean problems later on. So note that this is a proportion problem. And the first thing we'll do is check our conditions. And so I think I'm going to go to a clean slide here to write down some of this stuff. Okay, so for the conditions, there were 4 of them. Your variable has to be categorical. So you're either a compulsive gambler or you're not a compulsive gambler. So that's categorical. So I'll just say variable is categorical. You need to have a random sample, and it does say that we take a random sample of 1,200 adults. So that condition's met. The third condition was that our sample size is less than 10% of the population. We sampled 1,200 people that live in Maryland adults. That's certainly less than 10% of all adults living in Maryland. And then the fourth assumption, sometimes we call that the success-failure condition. We have to have at least 10 successes, at least 10 failures. Well, we have 1,200 adults, 15 of them are compulsive gamblers, and so the other 1,185 would not be. So we do have both 10 successes and 10 failures. So 15 successes and 1,185 failures. These are both greater than 10. So our conditions are met, so we can go ahead and do our hypothesis testing. So for our hypothesis testing, we have to identify a few things. We're going to need p hat from our sample that we collected. What was the sample proportion of compulsive gamblers? We're going to need our sample size, and we're going to need that critical z-value that's based on how confident we want to be. So make sure you've jotted down the conditions, and I'm going to erase this and start with the problem. So if we note from the problem, the sample proportion. In our sample, there were 15 compulsive gamblers out of our sample of 1,200. This ends up being 0.0125 or about 1.25%. In our formula for confidence interval, we'll also include the percentage that are not compulsive gamblers, 1 minus that. So we'll write that down just so we have it handy here. Our sample size was 1,200. And then the last thing that we're going to need to construct our confidence interval is that critical z-value. Since this is a 99% confidence interval, Joe Cooper-Santa just showed you some of these in the last video, how you find those critical z-scores. We want 0.99 to be the area in the middle of the normal curve, and so that would fall between z-scores of plus and minus 2.576. So that's everything we need. Let's go ahead and get our confidence interval. Recall this was the formula. So we're going to sort of take our best guess for the proportion, plus or minus. Remember, we called this part the margin of error, and it incorporates there how many standard errors we want to jump out from that best guess. So we have everything we need. We're just going to plug the values in here. So our sample proportion value was 0.0125. We'll take plus and minus that z-score. Here, we've already computed 1 minus, so I'm just going to put the 0.9875. And our sample size was 1,200. Go ahead and, it's good practice to compute that margin of error part first. So if you compute just this, the margin of error is about 0.0083. And now we're going to take that sample proportion minus the margin of error. When we do that, we get a lower bound to our confidence interval of 0.0042. And then when we add the margin of error, the upper bound of the confidence interval there goes to about 0.0208. We often put the confidence interval in a set of parentheses. We call this interval notation. Make sure that you're writing the smaller number first and then the bigger number, just like you would on a number line. And then along with confidence intervals, we'll always interpret our confidence interval. You know, what does this tell us? Here they're written as decimals. You can multiply both of these by 100 and think of this as percentages. We were constructing a 99% confidence interval, so we're 99% confident that somewhere between 0.42% and 2.08% of adults in Maryland are compulsive gamblers. So to interpret, we are 99% confident and when we interpret, it makes a lot more sense to talk about these as percentages. That between 0.42% and 2.08% of adults in Maryland are compulsive gamblers. So we'll always end a confidence interval by interpreting that so that we know what did we just find. Essentially, if we were to do this over and over again, if we did this again and collected a different sample of 1,200 adults, probably wouldn't get 15 that were compulsive gamblers. We'd probably get a different number. This value would change. Our confidence interval would be different. If we did this over and over and over again and looked at all the different confidence intervals, 99% of the confidence intervals would contain the true proportion of Marylanders that are compulsive gamblers, and 1% of them won't. That's sort of an explanation as to what the 99% confidence there leads us to. Okay, so that was one example. We're going to go on and do a second one. Let me erase this. All right, in the second problem, we're interested in whether or not students are using the PE complex. So let's see what this says here. Data was collected on campus to ascertain whether or not students are using the PE complex for something other than their regularly scheduled classes. So staff members visited an assortment of classes, polled students. Together, it turns out that there were 46 students that use the facility and 230 students that don't use it. Calculate a 98% confidence interval for the proportion of all Cecil students that are using the gym. Interpret your interval. And then when we're done, we'll answer this question. Does it seem the college is meeting its goal that at least 25% of students are using the facility? So we're going to see if we can use our confidence interval to answer that question. Okay, so first thing, let's start with our assumptions. I think I'll squeeze them on here and then I'll go to the next slide. So always check your conditions. So for our conditions, the first thing is that the variable, is it categorical? And you either are using the PE complex or you're not, so that's categorical. The second assumption is that you have a random sample. We went to an assortment of classes. It might not be a true simple random sample, but by going to an assortment of classes, it at least looks like our sample will not contain any bias. So sample appears to be unbiased. Clearly, it would not be a good thing if you only sampled the baseball team or only sampled students that are currently in the PE complex. But the sample here looks like it will be unbiased. Our sample size needs to be less than 10% of the population. So our sample size, we had 46 that use the facility, 230 that don't, for a total sample size of 276. We'll assume that this is less than 10% of all Cecil students. And then the last assumption there, we need at least 10 successes, at least 10 failures. We've got 46 students that use it, 230 that don't, so we do have at least 10 successes, 10 failures. 46, we'll say, are the successes, and 230 failures. Both of these are at least 10. So our assumptions are met, so we can go ahead and calculate the confidence interval. Again, we're constructing a 98% confidence interval, and this is still a proportion problem. So we're going to need the sample proportion again, our sample size, and then that critical z-value. So I'm going to clean this up, I think, and start on a fresh slide. All right, so let's summarize what we have here. We need our sample proportion. From our sample, what percentage of students are using the PE complex? Well, 46 students were using the complex. And then be careful, don't make that 46 out of 230. 230 of them weren't using it. Our total sample size was 276, both of those together. And so this is about close to 17%, 0.167. If we take the percentage then that weren't using the PE complex, that would be the other roughly 83.3%. Our sample size, again, was 276. Make sure you included both groups there. And the critical z-score that we'll be using. We want to be 98% confident. Again, in the previous video, Joe Coopersana, I think this was the last one we looked at, came up with this critical z-score was 2.33. If you were to draw a normal curve and put an area of 0.98 in the middle, the area in the middle is 0.98 when you're looking at the area between z-scores of negative 2.33 and 2.33. All right, so let's construct the interval. Here's our formula again. Our best guess plus or minus the margin of error. So our best guess as to the percentage as a decimal is about 0.167. The z-score we're going to use for this one, since we want to be 98% confident, we're not as confident as we were with the last problem, is 2.33. And then we'll take the square root of p hat. 1 minus p hat we've already done is 0.833, and all over our sample size. Again, let's compute this margin of error part first. Plug that in your calculator. Make sure you're taking the square root of all of this over here. And for the margin of error, you want to get about 0.052. And And then we'll take our sample proportion, we'll subtract off the margin of error. And when you do that, you get about 0.115. We'll take our sample proportion, we'll add the margin of error, we'll get about 0.219. You could also write this as with percentages. We're saying our confidence interval goes from about 11.5% to 21.9%. Percent. Okay, we got two more things to do. Let's interpret our interval, and then there was a question at the bottom of the problem that we'll address. So to interpret our interval, we were constructing a 98% confidence interval. So we're 98% confident that the true proportion of students that are using the PE complex is somewhere within this interval here. If we were to do this over and over and over again, construct multiple confidence intervals, 98% of them would contain the true proportion of all Cecil students that use the facility. So we'll write a sentence to interpret this. We are 98% confident between 11.5% and 21.9% of all Cecil students use the gym. Remember, your confidence interval is based on a sample, but we're making an inference about what's true about the whole population. So now we're making a conclusion about all Cecil students, not just the 276 that we sampled. And then finally, let's answer that question. At the bottom it said, does it seem that the college is meeting its goal that at least 25% of students are using the facility? Well, look at the interval that you got. You know, where's 25%? 25% is above this interval. Your entire interval is below 25%. So based on this confidence interval, it does not look like the college is meeting its goal. So to address that question, our entire confidence interval is below 25%. So this would give us some evidence here that the college is not meeting its goal. We could say that we're 98% confident that they're not meeting their goal. Okay, and that's the end of video C. Went through 2 examples with confidence intervals. Thanks.